Alright, so we're finding the inverses of exponential and logarithmic functions. So, in brief, functions which are one-to-one have inverses. So here we have a typical example. Here's a x-axis and a y-axis, very squiggly. And you'll see hopefully that the exponential graph is one-to-one. And going from previous knowledge, if we make a reflection around the y equals x curve, then you'll hopefully see that that is a logarithmic graph as well. So to calculate the inverse function, you've got three steps. 1, swap the x and the y. 2, solve for the new y. And 3, write the final equation. So here we're calculating this one. And our first step is to swap the x and the y. So we'll say let x equals 2 minus 3e to the power of 2y. And then here we want to solve for the new y. So my first step is to subtract 2 from both sides. That gives me x minus 2 equals negative 3e to the 2y. And then next I have to divide by the negative 3. Divide by negative 3. This will give me e to the power of 2y on the right. That's because these will cancel. And on the left, a little trick here. If that's a negative, then I can swap these order and change the signs around effectively. So I've got 2 minus x over 3. And then if you want to get y by itself, the next step is to get rid of this e by taking logs to the base e. So you can write log to the base e of 2 minus x on 3 equals 2y. And lucky last, you would have to divide by 2. So you have y equals a half log to the base e of 2 minus x on 3. Now you could also write log e as ln. Okay, that's the same notation as well. Just to be really clear, you can say the inverse function. Okay, so here's another one. We're finding the log of the inverse of a log function. So what we do first is the same as before. We let x be what y used to be. So you have y equals 2 minus log to the base e of y minus 1. And I rewrite that as this because it makes it easier to see later on what I'm doing. Now here I'll move this term with the y across so I have all positive. So if I move it across here, I'll get a positive log, which is log to the base e of y minus 1 equals 2. And then what comes after it is a minus x, because you bring it across here, you have to take away x. So you get 2 minus x. Then you would kick this e across here as the base, which means this is now the new index. So you have y minus 1 equals e to the power of 2 minus x. And then to do the final step, we have to get rid of this minus 1. So we have y equals e to the 2 minus x plus 1. If you want to be very, very clear, you'd say inverse function before that, and it tells you that's the rule for the inverse function there. Now, just a little note of notation. If we started with f of x equal 2 minus log of x minus 1, then we need to end with an inverse function in the right notation. So we'll say f with a little minus 1 x is equal to e to the power of 2 minus x plus 1.